So in 7.1, we are going to go with the, okay, what is going to be the law of the, okay, what is going to be the law of sines. Okay, it is going to be all sine functions. This is it. You see, we are going to have in this chapter altogether, and the way we are going to introduce the triangles are going to be, you see, if this is going to be a given triangle, we usually labeling the, okay, the angles by the uppercase letters, like A, B, C. So this is going to be for the angles, okay, uppercase. And then for the sides, this is the way we're going to go for it. So if this is going to be angle A, the opposite side. The opposite side would be denoted by A. So you must know that anything we do in this chapter, A is going to be the side opposite of the A. And over here, this is going to be called B. Okay, this is going to be called B, and this is going to be called C. So we go through this, this notation right through these three sections. Now, what is going to be the law of the sine? Law of the sine is something easy that gives you a relationship between the sine of the ABC and this value, if you like, ABCD. So just remind you what it is and where we are going to use it. So for a triangle in general, for a triangle with sides, the sides are going to be A, B, okay, A, B, C, and okay, and opposite angles, and opposite angles, and the opposite angles, which is going to be A, B, and C, as I talk about it respectively. Okay, respectively, this is what we are going to have. Maybe it's the one that we call it law of the sine. This is it. It's going to be the sine of the angle A divided by the length of the side, opposite side, A, is equal to, okay, is equal to the sine, okay, it's going to be equal to the sine of the angle B, opposite side, which is going to be B. And this is going to be equal to the sine of the angle C, okay, divided by the side C. So this is the one that we are going to call it law of the, okay, law of the sine. Okay, there are different ways to use this one. When you want to use it, we just use it 2 by 2 if you like. So this means you can have, okay, you can have the first and the second one. You can have the first and the third one, or you can have the second and the third one. Okay, so this is the way we are going to use it. Depends which one are you going to be interested in to use. Okay, so just remind you that, note that you can use this one, sine of A over A. You're going to have it with any angle that you need. So for example, in this format, it's going to be sine B over B if you need, or you can use this one, sine A over A is equal to the sine C over C. Okay, or you can use, if you need, you can use the sine B. Okay, the sine B over B equal to the sine C over C. We'll see in a minute that we look at the given information. You see, when you want to apply it, we look at the given information and we use the formula that we need. Okay, any question? Easy to remember. Okay, easy to remember, law of sine. Okay, even you can switch all of them. A over sine E, B over sine B, or the C over sine C. So we can consider the reciprocal of these numbers that you have. Now, how we're going to use it to solve, solve triangles. When the triangle is given to, some information would be given. this information would be related to the angles or related to the side length, okay? So depends which case are you given. So we are going to label them, all the possibilities, okay? So we are going to use it for solving. Okay, we are going to use it to solving triangles. Okay, but we know that they are not going to be right triangle, okay? These are going to be not right triangle. So in your book, this expression, they refer to it as a oblique, if you like, triangles. This means, the triangles that is not going to be, okay, triangles. That's not going to be a right triangle, oblique triangles. Okay, that's a triangle. And so the cases that we usually, you will realize it yourself, but these are the one that we are going to use, and you will see one from each on these examples, and then for your test. Okay, the law of sines. So the law of sines can be applied. Okay, law of sine can be applied for the following cases to solve. Okay, to solve, we're going to label this case. Okay, it's not something that you remember, you memorize, but it's good, would be nice to know. The cases that we can use is, we are going to call it SAA. So this means one side and two angles would be given. A stands for the angle and S for the side. Or you may have, two angles and the side in between. You see ASA. So two angles and the sides in between. Or the other case that you can use is going to be, you may have two sides and one angle. Okay, these are going to be the cases that we can use. Solve these or triangles, if you like. Okay, you don't have to memorize it, but as soon as you write the information, you realize. But these are going to be three cases that's going to be popular, and you must know that you are going to use the law of the sine for the following cases. Any question? So we have to give you one example from each. You consider it from each, and you see what is going to be the possibilities and how we're going to handle this type of problems. You need your calculator, of course. These angles are not going to be ordinary angles. Okay, and the other things that we assume that, that the sum of all the interior angles of a triangle is 180 degrees, okay? So you need your calculator, you calculate it in degrees for finding the results. It's going to be decimals. We're just going with 1 or 2 decimal points, most of the time 1, or sometimes the instruction would be given to you. Okay, so there you are. Let's go for it. Example, one from each. So we want to solve the triangles. Solve the triangle with the given information. The first case that I'm going to consider is going to be SAA. So SAA is going to be the case that okay, two angles and one side would be given to. This is the given information. The given information would be given symbolically, and you just use that law that we talk about it. You draw your triangle and you go for it. Okay, so A is equal to the 40, B is equal to the 60 degrees. Okay, 60 degrees, and the given side is A. A is equal to 4. Okay, that's the information that you're going to have. Two angles and one side. Okay, you have to draw a triangle with this information, and then you go for it. So this is going to be a triangle I'm going to consider. Okay, for example, this is the triangle. Okay, I'm going to call this one A, B, and C. Now I put the given information over here. Okay, so What's the question? Getting this information. Okay, that's going to be one. You know, it doesn't matter. If there is going to be a measurements, they are going to give you. Otherwise, they may give you without any units. Okay, so this is going to be one. So this is going to be degrees. Doesn't matter. We can call it, you know, centimeters, etc. It doesn't matter. Okay. So if it's given to, let's go for inches. There you are. Okay, so this is going to be the case. So you identify the information that you have. This is going to be a 60 degrees. Okay, so that's going to be 60, and this is going to be 40 that we have. Now the side is A, so opposite side. So this is going to be equal to the 4. So the missing parts are going to be, C here, okay, and the B here, and this angle, of course, is missing. Okay, so this is the information that we have, and we are going to continue. Now, since two angles are given to you, you can find the third angle right away, okay? Because you have to have the three angles and the 3 sides. Okay, so for the solution, I go with the A plus B plus C. Okay, A plus B plus C is equal to the 180 or 180 degrees. So we substitute, we have the, okay, A is 40 and the B is 60. Okay, so the C is missing and this is going to be 180. Okay, 40 and 60 would be 100 and you subtract it, so C would be 80 degrees. So we got the three angles. Okay, any question? Now start working for the, okay, for these sides. Since you have the angles and you want to use the sine, okay, so you have the angle A and the side A. So you have to use sine A over A because you have these two together, okay? And then you have the angles for the other one. You can shade, you can take the sine A over A with either of those, with the sine B over B or sine C over C, okay? Because you have this A, so you have to use the A and the angle A. Okay, so one option is going to be, okay, so this is going to be one option. The one option is sine A. So I go with the sine A over A because I have both of them. Then I go with the sine B. Okay, sine B over B. Because we do have the angle B, okay? We do have the angle B, and if we substitute, so we can get the B right away. Any question? Now a substitute. A sine of A is 40 degrees, so it's going to be sine of the 40. Okay, the length is given to is equal to the 4. So this is going to be the sine of the B, which is going to be the sine of the 60. Okay, the sine of the 60 over the unknown, which is going to be B. Okay, it's just a proportion. You can find the B right away. Okay, so what's going to be the B? B is going to be, you multiply these two together. So it's going to be 4 sine of the 60 degrees, okay, divided by sine of the 40 degrees. Any question? Now we can use your calculator to get these numbers right away. Okay, you can substitute if you like, you know, by one, but the calculator will give you the result right away. Okay, so check if you have your calculator to make sure that you know how we arrive at the same answer. And make sure that your calculator is set on degrees because we're using the degrees here. Okay, so you know that this is just the ordinary calculator will give you the result, and you have the sine and the cosine here. So I'm going to try it. It's going to be 4. Okay, 4 times sine of the 60. Okay, sine of the 60. This is it, and then I want to divide it by sine of the 40. Okay, so this is going to be the result. Okay, it's going to be 6.38 and 9. Okay, that's one. So this is it. So B, I go with the 2 decimal places for this one. So that give me 5.39. Okay, 5.39. We use the measurements to be inches. So that's going to be inches. So officially your B is going to be, B is equal to the 5.39 inches. So that's going to be your B. Any question? Instruction may be given to you for the rounding. Okay, how much are going to round it? So 6 or 5? No, it's 5. No, it's a 5.39. You can check it again with your calculator. Okay, make sure your calculator is in degrees. It's a 4 times the sine of the 60 divided by, okay, sine of the 40. I have 5.39. Okay, any question? Anybody try it? Get the same number? Let's make sure we get there. You can see the same numbers. So that is going to be the B. Okay, then we can use the same thing over here. You see, because we have the angle C, and then you can use the sine. Okay, you can use law of the sine to get to get the other one. You can go with the A, or you can go with the B to get this number. Okay, very good. And so we continue. I put it here so that we can have it. Okay, so let's go with the other one. The C is missing, so I go with the sine of A. You can go with the sine of B if you like, and we stay with the sine of A over A. So the missing one is C, so it's going to be sine of the C. Okay, sine of the C and the C here. Again, we continue. The sine of the A is going to be sine of the 40. Okay, measurement was 4, is equal to the sine of the C, which is sine of 80 degrees. Okay, 80 degrees divided by C. Again, cross multiply to get your C. So C is going to be equal to 4 sine of the 80 degrees divided by sine of the 40 degrees. Again, use your calculator to get these numbers. So my result is I have a 6.13 inches if you like. Again, use your calculator. Make sure you arrive at the same numbers, for the test. So there you are. We have the ABC. You see ABC and the angles in order. That's case 1. We give you one of them. Okay, this is going to be the case that we have. Okay, that was the case SAA. We did have one side and 2 angles. Okay, any question? So let's get another type. This type is going to be 2 angles and the sides in between. Okay, so these are the one that we talk about it. Okay, so we did this one, so we have to do this part over here. This last one is a little bit tricky, but we can do it. Okay, so be careful, not difficult, but make sure double check. Make sure you get the correct answer. So let's check the second one, the second case that we have. The second case that we are going to consider is going to be ASA. So the angle A is given. Okay, the angle A is 35 degrees. This is going to be the angle A. And then we have the angle B. Angle B is 15 degrees. 15 degrees, and we have a side in between. SC is equal to the 5 inches, for example. Okay, so this is going to be the case of ASA. So 2 angles and the sides in between. Okay, again, draw the graph of a triangle that we have. Okay, so this is going to be the solution that we have. Angles is 35, and and the 15. So something like this is it. You can go with the general one and just label it. So generally, if you are going to call this one ABC, okay, this is going to be the ABC, and the information that we have is this A is 35. So we have the A 30, 35, and you have the B, which is going to be equal to the 15. Okay, and the side in question is going to be there between. This is the side C, which is going to be 5. Okay, 5. So the missing one is A. The missing one is A, and is going to be B. And of course, the angle C, which can be found easily. Okay, so that gives you a picture of what you are looking for. Okay, are you ready? We are going to find the angle first again. So that is ABC altogether is 180 degrees. And you have the A and the B, so that will be 35. Okay, 35 and 15, and the C is missing, which is going to be 180. Okay, so that would be 50. Okay, so this is going to be 50 plus C, which is going to be 180. So the C would be 180 minus 50, which is going to be 130. Okay, so the C is going to be 130 degrees. So this is the C. Okay, so we have all the angles. Now we are going to find the sides. So we check to see what we have. You see, this is going to be the case. We have this is going to be the C, and we already got the angle C, so 130. So this must be one of them, because it's going to be sine of the C, which is known, divided by A. So then you can pick it with any other two, because you have the angles over here, and we can find the A and the B, and then do that. Okay, so the formula, it must be, you must start with a sine C. Okay, sine C over C, because you know both of them. Okay, you know both of them, then you take it with the other two. So for example, you can go with the sine A. Okay, sine A over A to find the sides A. Now we're going to substitute. So we get the sine of 130 degrees. Okay, divided by the C. C is given to is 5 inches. Okay, is equal to the sine of A. A is 35 degrees, so it's going to be sine of 35. Okay, over A, which is the missing part. So this is going to be the case. Okay, what's question? To get this one, my internet is, it seems to be all right here. From this side is all right, everything. Okay, any problem? Can you sit down? So I don't have any problem with my, from my end. Okay, so we are going to substitute to see what we are going to have. We get the substitution. Okay, we want to find the A. So cross multiply. So your A is going to be equal to, A is equal to the 5 times sine of 35. Okay, this is going to be 5 times sine of 35. Okay, divided by sine of 130. Okay, 130 degree. Again, you can use your calculator to get these numbers. Again, make sure you're okay. You set it in or on degrees. Check with your calculator to make sure that you get these numbers. Okay, I have 3.74. So it's going to be 3.74 inches. So my A is equal to the 3.74, okay, inches in this case. So check, make sure that your calculator gives you these results. Okay, so we have the A. So we are done with the A because we have the A and we have the angle A. So we repeat it again for the B. Again, we can use the A or the C, but we already got the C. So I go again with the sine of the C over C, and I go with the B this time. It's going to be sine B over, okay, sine B over B. So go back and substitute again. So this is going to be again sine of the 130 over 5. Then go with the sine of the angle B, which is 15 degrees. 15 degrees, and the side B is the missing one. Okay, cross multiply to get the B. So B is equal to B, these two. Okay, it's going to be 5 sine of the 15 degrees divided by the sine of 130 degrees. And if you use your calculator, you must arrive at 1.69. So B is equal to the 1.69 inches, and we are done. Any question? So these two cases are straightforward, and you can't miss it. Just make sure that you don't miss any numbers when you substitute for these cases. Okay, so that was the case 2. The case 2 that we do have two angles and the side in between. Now we are going to go to the third case. This is different. This third case is where two sides and one angle would be given to. Okay, two sides and one angle would be given to, and for this one you may get the various possibilities. Okay, so let's see what is special about this third case that we have. Any question? So straightforward, but just make sure your numbers are going to be are correct. So what is going to be this third case, which is would be different? Let's see. This is going to be the case that the information would be given as are going to be two sides. So A is given to you, for example, A is equal to the 3 inches. Okay, that's one side. And then we are going to have another side. B is equal to the 2 inches. Okay, but you have only one angle. Angle A equal to the 40 degrees. You see, in order to be able to do it, you need to find one more angle, if you like, to get this information. Okay, to go back to be able to do it. Let's get the graph to see how we check the information that we have. So if this is going to be, we can graph this one as you like. This is going to be your A and the B and the C. Okay, let's see what the information that we have. We have the angle A, so we have this one, which is going to be equal to the 40 degrees. Okay, so we don't have the side A is equal to 3, so this is going to be 3. The side B is equal to 2, so this is going to be 2. We don't have the side C, so we have to find the C here. Okay, and you don't have these angles. You don't have the angle C, or you don't have the angle B. So you have to find one of the angles, okay, because you don't have enough information to do it. And so you try to see how you're going to apply the sine, sine formula. We have the angle A and the opposite side. So we can use this one as one part. So we can use sine A over A, sine A over A, and we can match it with the others. So we just look, we have the opposite side of the B. So the angle B is missing. So if you use the sine formula for the sine A over A and the sine B over B,
Yes,
you'll be able to find the you'll be able to find the angle B. Okay,
but
so
we
this
will,
is how we're going to go for
but
it.
we will take shift on the calculator
Hmm.
to find the real B.
Yes, yes, that's it.
Yes.
So this is it. We go for it. So it's going to be sine A over A. Okay, sine A over A, and we go with the sine B over B. Okay, then you substitute. If you substitute, that gives you sine of the 40. Okay, we get the sine of the 40 over A, which is equal to 3. Then this is going to be equal to the sine B. Okay, it's going to be sine B over B, and the B is equal to 2.
Yes.
Okay, so we have the B2. Now we cross multiply to find the unknown that we have. The unknown that we have is sine B. The angle is missing.
Yes.
So this is going to be a cross multiplication one. Okay, so this is going to be the sine B, which is going to be equal to, is going to be 2 times sine of the 40 degrees. Okay, divided by 3.
Mm-hmm.
So we are going to simplify this one first, okay, by getting the information with the calculator. If you do it with your calculator, the sine B, okay, the sine B would be 0.43.
Mm-hmm.
Okay, this is going to be the sine B. So what we're going to do, like an equation that we talked about it before, you have to find the B. In order to
Yes.
find the B,
Shift.
we can use the sine inverse from your okay, for your calculator. So because the B is going to be, if you like, B is going to be equal to what? Is going to be the sine inverse of the 0.43. That is going to be the situation you're going to have. So you go to your calculator, okay. You know that instead of, we have to get the second, then the sine, click the sine, that give you the sine inverse. Okay, so we are interested in the sine inverse of 0.43. The sine inverse that give you, this is it. So that give you 25.46. So I'm going to run that, and I pick the, that's it. I pick 25.4. Okay, it doesn't matter
Mm-hmm.
a little bit up and down to get these numbers. Okay, so we pick the B, and the number that I use is 25.4 degrees. Okay,
Mm-hmm.
so or 5, it doesn't matter. Now, the point about this idea is going to be that you got to be careful. Remember, when you solve these type of equations, when you think about it as when you think about it as the inverse function, remember when we used the sign for the inverse function, there was a limit. This angle is supposed to be between, between negative pi half and the positive pi half, remember?
Yes.
Negative pi. But in the case of these triangles that we're going to use, okay, in the case of the triangles that we use, the angles cannot be negative. So what we just look at the sine equation. Remember the sine equation? When you want to solve the sine equation, since the sine is positive, so we have two solutions. Okay, the solution that we consider is the one on the first quadrant, because the sine is positive. So on the first quadrant, that gives you 25.4 degrees. But the second one was what? The sine is positive also in the second quadrant. In the second quadrant would be 180 minus 25.4.
Mm-hmm.
Okay, so we are going to have two solutions.
Mm-hmm.
Solutions are going to be the first one, if you like. The first one, this is just 25.4 degrees. Okay, this is one of them. And the other one is, okay, you have another b. If you like, you can call it b1 and b2 or just b. And the other one is going to be 180. Okay, 180 minus 25.4 degrees. Okay, then the result is going to be 154, then 0.5 degrees. Okay, so this is going to be another possibility for the B,
Mhm.
154.5 degrees. So you have to check to see, are you going to use both of them to continue your problems, or are you going to use only one of them? So you have to check to see what is the other measurements of your angle. You should look at this one. The other angle that we have so far is 40.
Mhm.
So 40, you know that you are going to add these two together and you take it out of 180 to get the C. So if you consider to B to be 154, then you have the A equal to the 40. So if you add them together, the sum is going to be what? The sum is going to be bigger than 180. So this
Yeah.
means this is not going to be,
Mhm.
okay, a good solution, okay?
Mhm.
Because you have to think about the next part. So when we get this one, we say that, oh, bad. Okay, that's one. But this is going to be the case. So the situation we're going to have, would be A plus B, if you like. A plus B would be 40 degrees plus 154.5 degrees, okay? And whatever this is going to be, this is going to be what? It's going to be 194.5 degrees, which is bigger than 180, okay? Because, the sum of three angles must be 180. But you add two of those angles together and you get 190 degrees, okay? So this means this solution is not going to be valid. So the only solution that we are going to consider is B equal to the 25.4 degrees. That is why this third case is going to be, uh, they call it ambiguous case, because you don't know very much in advance that how many solutions are going to have. You may have one solution, you may have two solutions, or you have no solution, okay, for this type of problems. So you got to be careful and you have to check the other possibilities that we are going to have. Any question? So this is happen only for this third case. The third case that you have okay, you have only one angle. You have to find the second one. Okay, so the valid one that we accept is this one for the B. Okay, this one for the P, so we can find quickly what is going to be the angle C. Okay, so what we are going to do, we are going to find the C. We know that the A plus B plus C is equal to the 180. Okay, 180. So you already got the 40 degrees for this one. Okay, 40. And for the B, you have 25.4. So the C is missing, equal to the 180. Okay, so if you move them to get the C, so what is this one? This is going to be 65. This is going to be 65.4. 65.4 plus C is equal to the 180. So we can find the C. So C would be 180 minus 54, 65. 65.4. And if you subtract it, the result is going to be 114, okay, 0.6 degrees. So C is going to be 114, okay, 0.6 degrees. Okay, so you've got to be careful. Just check this one, and then continue. Okay, because the solution, you have to consider the solution between 0 and pi, 180, and then you may have two solutions. Okay, any question? We are not done. So what else do we have to do to get these numbers? So far, we have the three angles. Okay, we have three angles and two sides. We have to find the last side that's missing is the side C. You see, you find the angle C, but you don't have the C here. Then you can use, the sine law again for one of them. It doesn't matter because you do have all of them. Okay, to get the C, I go with this one. I go with the sine A over A because I have both of them. And this is going to be the sine C over C over C. Okay, now substitute. Your A is 40 degrees. So this is going to be the sine of the 40 degrees. And the A is equal to the 3. That was the 3 inches. Okay, and this is going to be equal to the sine of the angle is 114.6. Okay, 6 degrees if you like, divided by C. C is the missing one. Okay, cross multiply because the missing one is C. So your C is going to be cross multiply. So this is going to be the 1. So it's going to be 3 times the sine of 114.6. Okay, and this is going to be divided by the sine of the 40 degrees. Okay, these are all degrees. Okay, you go to your calculator and you check these numbers, and you have to check it. Make sure you get this one. It's 4.24 inches. That is the one that I have. Okay, so this case, and that's a type 1 of the third case, and we're going to have a couple of more. So you got to be careful about this one. That when you find this angle, double check. You may get another one. You will see in a minute. You may get 2 angles that both of them are going to be good. So we have to. Then we have 2 solutions. In this case, we have only one solution. Okay, we have one solution with this information that we got over here. Okay, any question? So we have to give you another case of this type SSA, if you like. Okay, so that was the type that is a little bit involved. Okay, so make a note that this is the type SSA. Okay, this is the type that we don't know at the beginning to see if this is going to be having a solution or what is going to be the solution. Okay, any question? Let's go and have another example of this type to see what would happen with the other possibilities. Okay, so let's see what we can have. This is a number 4. And number 4, the one that I have is this one. This is going to be interesting. Okay, so this is it. A is equal to 6. Okay, 6 inches. That's the side A. Then we have the side B. Side B is equal to the 8 inches. Okay, and we have the angle A, which is equal to the 35 degrees. Okay, let's see what would happen to this one. Again, the case is, as you can see, the case is side, and angle. Okay, let's get the graph of this information to see what is going on with this one. Let's get, get a triangle. Get the ABC here. So your ABC, just bring the information that we have. So we have the side A, so this is going to be 6. And we have the side B, which is going to be 8. And for the angle, we have the A. Okay, the angle A, this is going to be 35 degrees. Okay. Now to start with, we can find the angle B here because, this is going to be the one, sine A over A, sine A over A, and the sine B over B this time, okay? Sine B over B, so we can find the B, and then we get the C, and then that would keep us going, okay? So we go for it. This is it. We go with the sine A. Okay, sine A over A equal to, okay, that would be equal to the sine B. We go with the sine B over B. So we substitute. A is 35, so it's going to be sine of the 35 degrees. Okay, divided by A, which is equal to the 6. The sine of B is the missing part. Okay, over B, B is equal to the 8. Cross multiply, and the unknown is sine B. So we go for it. The sine B is going to be equal to, the 8 times the sine of 35. Okay, divided by 6. Again, we are going to use calculator to get to see what's going on with for this number. Okay, you can check your calculator, but the number that I have is 0.76. Okay, that's a 0.76. So the sine of B is equal to, okay, is equal to the 0.76. Okay, then you have to go and find what angle this would represent. Okay, if you use the sine inverse in your calculator again, that gives something like 49.9. Okay, so the conclusion is going to be that give you B equal to, okay, B equal to the 49.9. Okay, and there's going to be left over, remember, two solutions. The other solution is almost 50 degrees. So the other solution would be 150 minus 50, that give you 130. Okay, 130. And the angle that you have is a 35. So even if you have a 130 and 35, that give 165. So that is going to be possible, and that would be useful. Okay, so we are going to call this one B1. Okay, and then we are going to have another one. So the other one is or, okay, or you get a B2 if you like. So the B2 would be 180. 180 minus, okay, minus 49.9. And that give you 130, okay, 130.1. So the possibility angles are B1 is equal to the, I repeat it again, 49.9. Okay, and the B2 is equal to the 130.11 degrees. Okay, and we check to see if it's going to be possible. Yes, it is, because you have to add it to the A. Okay, then subtract it out of 180 to get the C. So you must have a leftover. In this case, we do have a leftover, because that would be 65, and this would be also the case. So both of them are going to be a valid angle, and we can continue. So in this case, we are going to have two solutions. Okay, any question? So that's why this case is unpredictable. The case 3, you may have one solution, or in this case, you have two solutions. Okay, so we take each solution one by one, and we continue. Okay, so we have to find the angle C for the second, the next part. Okay, so what is going to be the angle C? We have the A plus B plus C is equal to the 180. Okay, that's going to be 180. And then you know that you solve for C. So we are going to have two possibility. If you go with the B1, okay, if you go with the B1, which is equal to the 49.9, so the A is 35. So it's going to be 35 plus 49.9 plus your C, which is going to be equal to the 180. Okay, you add them together, then you subtract. So what's going to be your C? So your C is going to be, we are going to add this, it's going to be 180. Okay, it's going to be 180 minus what? This is going to be 4 and 9. It's going to be 14, 580 84.9. Okay, 84.9. And if you subtract it, so that give you 95.1 degrees. Okay, so we have one angle C, we call it C1 because there is going to be another one. Okay, so the C1 is going to be equal to the 95, okay, point one degrees if you like. This is going to be 0.1. Okay, so this is going to be one of your angle. Any question? We have one more to go. We have the B2 equal to, so B2 was equal to the 130.1 degrees. So we do the same operations. Okay, then you subtract to substitute A plus B plus C equal to the 180. So in this case, it's going to be A is 35. So it's going to be 35 plus 130.1. Okay, 130.1 and plus the C. This is equal to the 180. Okay, so if you add them together, that give you, okay, it's going to be 165. So 165.1 plus C. Okay, this is going to be, okay, we call it C2, or at the end we call it, it's a C2, call it C2 equal to the 180. So you subtract that. So the C2 is going to be, if you subtract, you see 180 minus 165.1. So the C2 is going to be, okay, is equal to the 14.9 degrees. So this is going to be your C2. Okay, so we have two solutions. We have two solutions because both of them are going to be valid. Okay, we are not done because we just identified the angles. Okay, we have one more side to go, and the side in question is, of course, the side C is missing. Okay, so again, you have to consider two different cases because you have two C numbers. Okay, any question? So this is, the case that you have to consider. So it's going to be more. I go to the next page. Any question on this one? So you have the C1 and the C2. So you have to consider both cases. Don't miss it. So we continue to get the, okay, to get the side C. So you have to use the sine law, if you like. So this is it. I start with the sine A. I can use the A or the B. Sine A over A. Okay, sine A over A, and this is going to be the sine C. Okay, sine C over C. I call it sine C1 because I have to use two different cases. Okay, so we go with the C1 first. So this is going to be the sine of the A. A is 35 degrees, and the sides of the A was 6. Okay, this is going to be equal to the sine of the C1. Okay, remember the C1 was 95.1 degrees divided by the side C, which is missing. Cross multiply. So your C is going to be equal to the 6 sine of the 95.1 divided by the sine of 35. Okay, you have to use your calculator to get this number. I have 10.42. So 10.42. And this is going to be, now we call it C1 because we are going to have another one. So this is going to be the first triangle. Okay, so because we have two solutions for the C, So automatically you are going to have two solutions for the side C. Okay, any question? So we continue to get in the second one. So we repeat it, but the angle is going to be the other one, that 14.9 degrees. So we repeat it again. This is the sine A over A, okay, equal to the sine of the C2 over C again. So the first part is going to be the same, is the sine of 35 over 6. Okay, 35 over 6, but this is going to be the sine of the second angles. Okay, the angles is 14.9. That was 14.9 degrees divided by the side C again. Okay, so this is with the with the second angle. So use cross multiplication. The C is going to be equal to, okay, it's going to be equal to the 6. Okay, 6 sine of the 14.9 and divided by the sine of 35. Okay, use your calculator. It's going to be 6 over the sine of the 35. If you use your calculator, so the result is going to be, I have 2.69. I call it C2 inches. Okay, just check to see if you get the same numbers. Okay, that was sine 35 over 6, and we have these numbers. Okay, check this one. Make sure you get the same numbers. The other one was 1042. Okay, let me check this one because in my notes I have something strange. So I want to check it. Okay, so what we have is going to be 6 times 6 times the sine of 14.9. Okay, then I divided by the sine of 35. Yeah, that's correct. 2.69. Okay, so this is going to be, the other option for this case of the two sides of an angle. Okay, so be careful. Make sure don't miss it. If there is going to be a possibility that you have to go and find, okay, a second solution. So you may have one solution or you may have two solutions. And there is one more case. The case that you may not get any solution for this case. That's why they call it ambiguous case, because you don't know what would happen to it. You have to check it to find out. Okay. Any question? Let's check to see what would happen that you may have to say that there is no solution. So that's going to be our last example for the sine formula. Okay, law of sine. So let's see what would happen. This is the information. A is equal to the 2 inches, for example. This time you have the side C, which is going to be 1 inch, okay? And then you have the angle C. The angle C is 50 degrees. Okay, so this is again the two sides and an angle. To get this information, okay, so get the information on the graph of a triangle to see what is wrong with this one. So you have the case here. Okay, so we have the ABC. This is going to be the ABC. So the information that we have is that we got the A is equal to 2. We got the C, which is equal to 1. and this angle, which is going to be equal to the 50 degrees. Okay, again, you have to check to see if you can find another angle. So we have the angle C and the opposite side. So we can use the sine formula starting with the C. Okay. So this is going to be your case. It's going to be sine C divided by sine C divided by C. And the other information that you have is you have the A. So we go with the sine A over A. Okay, substitute. So this is going to be the sine of the sine of 50 degrees. Okay, sine of the 50 degrees. The length, the C is equal to 1. Okay, is equal to the angle A is missing, so it's going to be sine of A and divided by A is given to is equal to 2. Okay, if you cross multiply this time, what's going to be the result? If you cross multiply, so you are going to have the sine A. Okay, sine A is going to be equal to the 2 times sine of the 50 degrees. Okay, you know that the sine is going to be between, in general, it's going to be between -1 and 1. But if you find the sine of the 50 degrees with your calculator, multiply by 2, so this result is going to be equal to the 1.53. You know that the value of the sine cannot exceed 1. So 1.53 is bigger than 1, which is impossible. Okay, so you won't get any solution for this one. So it's not going to be possible. So there is no solution. So this last case is really ambiguous. So you got to be careful when you're dealing with the last case. You may get a solution or you may not, or you may get one solution. You may get one solution, two solution, or none if you like. Okay, so be careful about it and don't be surprised if you get the possibility. So double check always when you're dealing with this, this case over here. That's it. This is the sine, the law of the sine. Any question? So we give you now a couple of application problems at the end so that you see what is going to be on. Okay, what's going on with this one? And this is going to be the case. There is one application I can give you. This application, it's very similar to one of the problem in your book. I want just to explain it. So you see how we're going to use this sine information that we have. Okay. Any questions? So be careful about the last case. The other two are going to be easy, but we get one of them. For this last one, we give you one. So it may be one of those three possibilities. Okay. You may get two solutions, one solution, or none solution. Okay. Let's give you this, explain this problem. There are some easier one, but it's not bad. But I want just to explain it to understand the problems. I'm going to use these sign. So in this problem, they are going to, you see, suppose you want to measure a height of a mountain. Okay, this is the example that I'm going to explain. This is, the idea is find, you would like to find the length or the height. Okay, height of a mountain. This is it. Now, to measure it, we send somebody to measure this one, and they are going to have two different measurements, and eventually they want to decide. Okay, let's explain the situation. The situation is going to be to measure. Okay, to measure the height. We made up something, we give you this one, and you have a couple of them in your final review, you said. To measure the height of a mountain. Okay, that's one. So we send somebody, he is going to be a surveyor. Okay, we send somebody and he takes, takes two sighting, two different measurements, different places. The sightings of the peak. Okay, of the peak at a distance which is going to be 900 meters apart. Okay, so we measure at one point and then we go on to the other position and we measure it again. Okay, this is when 900 parts apart on a direct, on a direct line to the mountain. The direct line. Okay, direct line to the mountain. I'm going to graph it and explain it in a minute. Okay, so two different sites, and the distance between the sites of the measurement is 900 meters. Okay, now the information are going to be the first observation results in, okay, the first measurement or observation. The first observation results in an angle of of elevation of 47 degrees. Okay, this is the angle that you look through it to get it. And the second one, and the second results in an angle of elevation of 35 degrees. Okay, two different positions with two different side angle, if you like. Now, if the transition, okay, if the transit is 2 meters high, you have to stand and measure it. Meters high. So we want to know what is the height of the mountain. What is the length of the mountain, or the height? Length or height of the mountain. So that's a question that that we have. It's a very nice application, and you have to be very careful, to draw that triangles that you want to use to get the result. Okay, now this is a situation that we're going to have. You see, you are going to be standing down here, and you do your measurements. You see, this is going to be the one. So the way they measure it, they start with the first part. Okay, this is the first sight seeing. Okay, I call it A. The first measurements happen at the angle of, one of them is 47 degrees, the other going to be 35. So I get the 35. You see, this is going to be the 35 to the peak. Okay, this is going to be the peak of the mountain. And the angle that's used over here is that 35 degrees. Okay, it's going to be 35 degrees. So we look at through this angle, and then what we did, we move here as much as, okay, we move here as much as 900 meters. Okay, we get the 900 meters here. Okay, and we pick another side. So this is going to be, we call it C, and then we're going to look at the mountain again. Okay, so this is going to be how we look at the mountain. But we look at the mountain this time at the angle of what? This angle, the second part is going to be for the 7 degrees. It's going to be for the 7 degrees. Okay, and we do have two different measurements. And over here, this is going to be this is going to be the height, if you like. Okay, this is going to be the height of the mountain. Okay, that's going to be the top here. So what you would like to do really, you would like to do, hey, to find this one. Okay, you may call it H to be able to do it. Okay, so these are the information that we have to be able to do it. Okay, so if you think about it, that you want to connect them together to get the H, okay, we want to use somehow the sign, okay, the sign formula to get this one, and you just look at the information that you have. You need one angle, okay, and the opposite side. This is going to be H, okay, the H is going to be a length, okay, this is going to be a length that we're going to have, okay, eventually. And if you consider in that big triangle over here, you see if it's going to be considered this big one. So the situation is going to be, this is going to be your H, okay, and the opposite of the 35. So you need to pick one more to be able to do it, okay, to be able to do it over here. And this is going to be, oh, the other things that we have is, oh yeah, we have the transit is going to be, that's something that we are going to use at the end. Okay, so this is going to be the case. You have to do something to be able to get the more of these numbers to be able to do it. So we can have the, if you have this angle, okay, that would be useful, okay, to start with. And the other things that you have, you see, this angle is 47. This is going to be 47, and you know that the total angle over here is going to be 180. Okay, this is going to be 180. So what you can do is you can find the angle C here. I mean the C inside, you see, the C inside. Okay, so the total one is going to be 180. So the first thing that you can do is you can answer this, find the angle C. I want to focus on this triangle. So we can find the angle C. And so the angle C is going to be 180 minus 47 degrees. Okay, and that gives you 133 degrees. Okay, so we have the angle C, which is going to be 133 degrees. Okay, which is going to be very good. So now this is a 35 and this is 133, then you can find this one because you have this 900. We want to use this 900. Okay, this is going to be 900 is possible. So so we find the opposite angle. Okay, so this is going to be 180. So inside this triangle, if you like, the angle B, what is going to be the angle B? Is going to be 180 minus the leftover. Minus, you have the 35 degrees here. Okay, you have the 35 degrees here, and 133 is just the C. Okay, if you put them together, what's going to be the result? This is going to be 180, and this is going to be 168, 168, and the total is going to be 12 degrees. So we have the B. B is going to be what? B is going to be 12 degrees. Okay, so This is going to be a situation that we have so far. And what we can do here is going to be, you see now inside this triangle, you see, look at this inside this triangle. Inside this triangle, you have the B and the opposite side. You have the B and the opposite side. So you should be able easily to find the C here. Okay, you find the C, and that will help you to be able to find the H here. Okay, so that's the idea of this problem. So this C is missing. You have to find the idea was finding that angle B. Okay, so I have the B and the opposite side, so I go with the sine B. Okay, sine B over B. And then I'm interested in the C, sine C over C. So this is going to be the sine of the 12 degrees. Okay, sorry, this is B. Okay, and the B is 900 meters, remember? That is a 900. So the angle C is, it's going to be sine of 130 degrees, 33, and the length C is missing. Okay. So as soon as you find the length C, then you can consider in that big right triangle, you'll be able to find your H. Okay. So cross multiply. So it's going to be C equal to 900 sine of 133. Okay, divided by the sine of 12. And if you use your calculator, this number is going to be a very big one. Okay, so that gives you 900 sine of 133. Again, if you may check your calculator, because the number that I have, so 133 times, I have to check it because my number seems to be a very big one. Okay, so let's check to see what's going to be the number about. So we have 900, you see 900 times it by the sine. Okay, the sine of 133. Okay, then and this is going to be the case. Then you divide it by the sine of the 12 degrees. Okay. Yes, if you divide it, the answer is going to be 3,165. Okay, 65.86. Okay, 86, of course, the measurement is meters. Okay, so this is going to be, okay, this is going to be the C. Okay, so we are ready to give it the height, because now we can find the height. In order to get the height, it would be very easy, because this is going to be a right triangle. You see the big one? This big one is going to be a right triangle. So what you can consider is the sine of the 35. Remember, the sine is the opposite side over the adjacent. Adjacent is the C, and then you'll be able to get the numbers. Okay, this is one problem in one of your assignment. You know, we give you something, it's going to be shorter, but this is not bad. Just, to get this information, really, it's a nice problem. Okay, so eventually this is it. We go with the sine of the 35 degrees, sine of A here. Okay, the sine of 35 degrees is going to be right triangle, the big one. It's going to be the opposite side, which is H over C. Okay, so this is it. If your C is going to be, so there's going to be H, and your C is 3,165.86 meters. So your H is going to be 3,165.86 times sine of 35 degrees. if you use your calculator, you get the H is going to be 1,816 meters. Okay, that's going to be the one. Okay, but the height of remember the transit that they use in order to get those angles, it was 2 meters high. Okay, so the height is going to be, okay, you have to add the 2 meters here. The height is going to be 1,816 plus 2. So it's going to be 18 meters. And that give you the result. Okay, the application that we have is a shorter form, but I just wanted to see this, this is a little bit more involved because you have to be careful when you consider these angles together. But let's give you just a sample of what is going on with this one. Okay, any question? I give you a break, and then the sine formula, this is it. We get the sine, those possibilities. Then we come back and we do the cosine. The cosine is much easier because there is one more case that we didn't cover. In all these problems, you did have at least one angle. So what if you don't have any angle, okay? So the other case is going to be the case that we have the sides all together, SSS we call it. Okay, so we're going to introduce the cosine formula, which is very important, even you use in physics really. There is an argument that we use the angle between two vectors. We defined the angle of two vectors even in three-dimensional. So you can define the angle between two lines in two-dimensional. When we get to the three-dimensional, we need this idea. And that would be very crucial, this formula that we're going to have. Okay, we introduced that one, and this is very short form. And then we finish it. That's it. See you in about 10 minutes. Okay, that was 7.1 of this section. Okay, so that was 7.1, law of the cosine. Then we have a law of a sine. Then we're going to have a law of a cosine, which will solve one case. Okay, it can be, use it for two cases. I told you, in future, there are going to be some more important application rather than solving a triangle. Okay, but we talk about it so that you know that this, when they refer to it, so you have the information that what they are talking about. Okay, so that would be 7.2. Okay, that's 7.2, and this is what is the law. Okay, the law of cosine. Cosines. Okay, that's it. So law of a cosine is going to be in this format. You see if a triangle is given to you. This is going to be a triangle. This is going to be A, B, and the C. Okay, and you have the A. This is the side A, the side B, and the side C. Okay, so this law is something very, it's not exactly the same, but in the line of the Pythagorean identity, if you like. So it's going to be in this format that if you consider the square of each sides, you see if you consider a squared is going to be equal to the b squared plus c squared. A square of one side is going to be the sum of the square of the other one, b squared plus c squared minus 2bc cosine of the angle between the b and the c here. You see the cosine between the b and the c is going to be a. So let me just write it down. So as usual for a triangle with this information, or a triangle with sides, with the sides A, B, C, and opposite angles, and opposite angles. The opposite angle is going to be A, B, C, respectively, as we defined it before. So this is going to be the case. So if this is going to be the case, we have, if you like, we have the following. So look at this one. Depends which side are you going to be interested in. If you are going to be interested in the side A, you start with the A squared. A squared is equal to the sum of the other two sides is a B squared plus C squared, minus twice of the BC. You see that's going to be 1, like the square of the binomial. So it's going to be B squared plus C squared minus 2BC times cosine of the opposite side here, of the opposite angle. You see that's 1. You start with the side A, so you have to end up with the angle A. Okay, that's A squared. Okay, so, if the three sides would be given to you, which is the case we are interested in, if the sides A, B, C would be given to us, we can use this formula to find the angle A. So that's the application that we're going to have. Okay, and similarly, if you would like to start with the B squared, now it's going to be the sum of the squares of the other two sides. So it's going to be A squared plus C squared minus 2AC times the cosine of the opposite angle. You see this is B, so you end up with the angle B. Okay, and then the other possibility, if you start with the C squared. So the C squared is the sum of the other twos, which is going to be a squared plus b squared. A squared plus b squared minus, okay, minus what? Minus twice of the 2ab times the cosine of the opposite angle. The opposite angle, the side is C, so the angle goes with the C. Okay, this is called law of the, okay, this is called law of the cosines. Any question? So in this case that you are going to use it is ABC would be given. You are going to be interested in the angle. But as I told you, in future, it's very important formula, very important formula. Because in future, as I told you, we are going to introduce two different vectors. Vectors is going to be, it's going to be a line. You start with the direction, is aligned with the direction, if you like. You see, sometimes some quantities can be measured with just the number, okay, like the length, height, area. But sometimes quantity would be measured with the numbers and the direction. So if you talk about the velocity, for example, when you say my velocity or the velocity of the car was 20 miles per hour, but you have to give us which direction, okay, southwest. You talk of the speed of the wind, if you like, so they give you those direction. So when you work on those type of environment, we would like to be able to define a cosine between two lines and angles between two lines. And this is going to be where we are going to use this formula. So it's going to be, very important in those type of ideas. But for the time being, we just wanted to know it. Just apply it for the triangle. And in future, if somebody say cosine, we're going to use cosine formula, so you know what they are talking about. Okay? Any question? So very easy to remember. You start with the given sides. The square of the one side that you are interested in is going to be sum of the square of the other two minus twice of the BC, but the cosine of the angle opposite to the given sides. There you are. The application, the main application is when three sides are given to you. So we want to solve, solve each triangle. How we're going to solve each triangle. And this is going to be the case one. Case one, three sides would be given. There you are. The side A is equal to 4 inches, for example. The side B is equal to 3. And the side C is going to be equal to the 6. Okay, so this is, they call it the case of the, SSS triangles. So three sides, no angle. All the other one that use formula for the sine formula, there was one angle involved, one angle was known. Then you'll be able to find the others, but not this one. Okay, so this is how we are going to solve it. If we get a triangle, so this is going to be A, B, C. And the information that you have, that this is A, 4. This is C, 6. Okay, and this is going to be B, which is 3. So since you have three sides, you cannot use the sine formula, you go with the cosine formula. Anytime you use the cosine formula, one of these angle can be found. And if you do it twice, two angles would be fine, then you can find, you can find the third one easily. So this is going to be a situation. It doesn't matter. You can pick one of them to start with because the information are the same. Okay, so what I'm going to do, I'm going to start with the A. So I know that the A squared is equal to the B squared plus C squared minus 2BC times the cosine of the A. So from here, I will get the cosine of the A, and then I can use calculator to find the angle A. Okay, substitute a squared. A is equal to the 4, so that would be 4 squared, equal to the b squared, which is 3 squared, plus the c squared is going to be 6 squared, minus 2 times bc. B is equal to 3 and the c equal to the 6 times the cosine of the a. Simplify, solve for the cosine. 4 squared would be 16. Okay, this is going to be 16 and this is going to be 9, 36. 36 minus 2 times 3 is 6, 36 again. 36 cosine of a. Okay, solve for the cosine of the a. So what is this? This is going to be 16. You get a 45. Okay, 45 minus 36 cosine of a. Okay, you just subtract the 45. So that gives me negative 36 cosine of a. Okay. Now, if you subtract it here, that gives you negative 29. So that would be negative 29 is equal to the negative 36 cosine of a. So eventually the cosine of a is going to be 29 over 36. 29 over 36. You can directly use your calculator to find use the cosine inverse to get this angle. Okay, if you use your calculator, you must arrive at a is equal to 36. Okay, 36.3 degrees. Okay, you know that the cosine is going to be positive in the first quadrant and the last one. So you are not going to get a second solution because in the angles, the sum of the angles is 180 degrees. So we get only one solution in this case. Okay, so that's going to be A. Any question? So you can continue now using, okay, you can use again the cosine formula to find another angle, or you can use, the sine formula. It doesn't matter. But the cosine seems to be maybe easier because you have those three sides. Okay, so you repeat it again. That was starting with the a squared, start with the b squared or the c squared to get those, the second one. Okay, so I go with the b squared, the other two is going to be a squared plus c squared minus 2ac, and the cosine of the angle, opposite angle is b. So you start with the b squared, this is going to be cosine of the b. If you start with the a squared, that would be the cosine of the a, okay? So substitute. So what we have is, this is it. We have the b is equal to the 3 squared, so it's going to be 3 squared. Then your a is 4, so that gives you 4 squared. C is 6, 6 squared, minus 2 times a, which is the 4. Okay, and the c is equal to the 6, then cosine of b. Okay, again, you can quickly simplify. So it's going to be 9 here. It's going to be 9, and this is going to be 16. 16 plus 36. 16 plus 36 and minus, okay, minus 48. Minus 48 cosine of b. Okay, so 16 and 36 would be 52. So this is going to be 9 minus 52. 9 minus 52, okay, is equal to the negative 48 cosine of b. Okay, 9 minus 52 would be, okay, that's it. It's going to be Okay, so that give you 43, and we have the 48, and then we can get the result. Okay, so that's going to be 43. Okay, I'm going to put it over here. So this is, we can find it here. Okay, so it's going to be 43. It's going to be negative 43 equal to the negative 48 cosine of b. Okay, cosine of b. So this is it. So the cosine of b is going to be equal to, okay, it's going to be equal to the 43 over 48. And if you use your calculator for the b, so your b would be 26.4 degrees. Okay, you have the A and you have the B, you add them together, take it out of 180, so that give you the C. Okay, it's going to be very easy case with this formula. Okay, so there you are. The C is going to be 180 minus A and the B. So we have 36.3 and the plus 26.4. Okay, 36.3 degrees. Okay, and you have here 26.4. And if you get these numbers, so C would be 117.3 degrees, the final answer. Okay, so that would solve the problem of the triangles to get these numbers done. So if three sides, sorry, if only, you see there is no angle here. If there was only one angle, you may use the case with the sine that we did have. Okay, for in this case, it was not possible. And sometimes the other previous problem can be solved for this system. I'll give you another one, but this is very unique. You can't miss it with the three sides. Any question? So I give you another one. It's not the three sides, okay, but you can use this formula if you like. So just to show you that there is a possibility you can go from one to the other one. Okay. So so that was the case one, and this is going to be the case two. The case two is that the A is equal to 2. Okay, A is equal to 2, B is equal to 3, and the angle C is equal to the 60 degrees. Okay, so in case these are inches or centimeters, doesn't matter really. Okay, so graph it to see how this information would be available. So if we graph it, this is it. The graph is going to be A. Okay, A, B, and C. Information that you have is this angle. This angle is 60 degrees, and you have the B, so this side is given to you, is equal to 3, and you have the A, which is going to be equal to 2. Okay, this is the information that we have. Let's see what is why you should use the the cosine formula. You can, this is the angle that you have. So you can, you see the previous one that you want to use you cannot find the other angle. Okay, that is going to be the case. You need another angle to find it. So you can consider the opposite side here. You see if it's going to be the opposite side and you have the opposite angle. Okay, So if you use the cosine formula, you start with a c squared. Okay, you have these two numbers and the angle in between. So quickly you'll be able to find, you find these sides. Or you can use the sine formula, because again, for the sine formula, you'll be in trouble because you have this angle, but you don't have the c. Okay, because when you use the sine formula, you need both of them. So that's why you need to use the cosine formula. Yes, you're right. You need to use the cosine formula in this case, okay? Although you will see one angle over here, but this is not going to be a useful angle, okay? So again, we have to use the cosine formula. So the C is missing. The opposite angle is given to you on the other two sides. So this is it. Use the cosine formula. C squared is equal to what? C squared is equal to the A squared plus B squared. A squared plus B squared minus 2AB. Okay, 2AB, the angle, opposite angle, angle C. And you have all the information that you need. So it's going to be C squared. Okay, your A squared, A is given, so it's going to be 2. So it's going to be 2 squared. Okay, 2 squared plus B squared, which is going to be 3 squared minus 2AB. A is equal to 2, B is equal to 3, and the cosine of the C, which is cosine of the 60 degrees. Any question? The information, this is it, C squared is missing. So that's a 9, that's a 4. Okay, that's a 4, and this is 9. And this is going to be 4 times 3, 12. So it's going to be 12. Okay, the cosine of the 60 degree is 1/2. Okay, 1/2, so that's good. It's going to be C squared equal to it's going to be 13 minus 6, which is equal to the 7. So C squared would be 7. You take the square root, not positive, negative, just a positive number. So C would be radical 7. You can use your calculator to measure it, but we usually write it down in the radical form. Okay, so we have the three sides now. A is equal to 2, B is equal to 3, and the C is equal to the radical 7. Okay, you need one more angle to find. So now you can use the sine formula or the cosine. The cosine is easier to find one more angle, okay? Because you have all the sides. Okay, so you can pick one of these angles, doesn't matter which one is going to be. Suppose if you want to find the angle A, so the opposite side is A is available, okay? So it's going to be A squared is equal to the A squared equal to the B squared plus C squared minus 2BC and the cosine of the A. Okay, this is going to be your formula. You substitute, you do have everything except the angle A. So this is going to be 2 squared equal to the 3 squared plus radical 7 squared, okay, minus 2. B is 3, and this is radical 7, and the cosine of A is missing. Okay, A squared equal to B squared plus C squared. Now 2 squared would be 4, 3 squared would be 9, so radical 7 squared would be 7, and this is going to be minus 6, radical 7, cosine of A. Okay, 9 and 7 would be 16. Okay, so it's going to be 4 equal to the 16 minus 6 radical 7 cosine of A. So you move the 16 to the other side, you subtract it. So that give you, subtract the 16. Okay, it's going to be 4 minus 16 equal to the negative 6 radical 7 cosine of A. So that gives you negative 12. And this is going to be negative 6 radical 7 cosine of A. Okay, so the cosine of A would be, cosine of A is going to be negative 12 divided by negative 6 radical 7. You can simplify it by 2, and then by the negative 2, you simplify the top and the bottom, but you have to use your calculator eventually. It's going to be cosine of A is going to be 2 over, okay, 2 over radical 7. So use your calculator to get the A. Okay, if you use your calculator, the angle A is going to be 40.9 degrees, almost 41 degrees. Okay, so it's a kind of another application of this formula. We have the A and then we have the C, so we can find the angle. Okay, remember the angle C is also known. C is known as 60 degrees, so we can easily find the B. A plus B plus C is equal to the 180. Okay, so the unknown one is B. So B is equal to the 180 minus the sum of the other two, 40.9 plus 60 degrees. Okay, so the inside would be 100 and it's a 180 minus 100.9. So the result is going to be the angle B is going to be 79.1 degree, and you're done. Okay, so it's very easy argument. As I told you, important formula for the application in future. So that is going to be everything we need to know with these two great formula. If you like, we are done officially. Okay, we don't need anything else, but in section 7.3, there is one formula for the area of a triangle. I like to give you that one too, okay? It is not going to be a difficult formula, but there are a couple of places in future you may have to use it, okay? So we can give you one question on this one on the final, which is very easy, okay? So I give you that formula too, then we are done. Okay, any question? So again, you can bring the formulas to the test, don't miss it. As you can see, these are not difficult, but it's going to be numerous cases together, but get practice, make sure that you are ready to use, which formula are you going to be useful for this case, and then, then you'll be fine. So the last thing that we do is this nice area formula that is going to be used sometimes in application problems in future. It's not bad because anytime you talk about, the area of a triangle. So you know that the area of a triangle is what? Is half of the product of its base and the height. So that is what you know in general. So if you do have the height and the base, you have nothing to worry about. But the question is going to be in general, it's not going to be the case that the height would be given to you, okay? So this would enable you to be able to do it because what we are interested in, that we relate everything to the trigonometric function or to the angles. And the angles are going to be more popular than the sides, okay? So that's the idea of this formula, okay? It's a 7.3, but I just get one example out of this and then we're done. They give you some other things, historically one, but we need only this one. Okay, so this is it. What is the area of a triangle? Area of a triangle, of course, in the trigonometric form, if you like. Okay, triangle. The area of a triangle is very popular. Any field that we have, eventually we want to, if we want to show off that our formulas are useful. We relate it to the area of a triangle. So that's going to be the idea. Okay, let's see how we can find it. Okay, I'd like you to prove it for you. So what is the original formula? Okay, let's recall. Okay, recall that. Okay, recall that if you give me a triangle, the area of a triangle, the area of a triangle, of a triangle is what? Is, because we use the A for the angle, okay, so we're going to use another notation. Call it K if you like. K is equal to the, you can call it anything else you like, but don't call it A in this concept if you like. You see, this is going to be the formula. Is going to be what? Is going to be the, you see, this is going to be your triangle. Okay, this is your triangle. And you know that this is going to be your base. So what you do, we are going to have your height. Okay, let's have the height here. This is going to be the height. Okay, this is going to be h. So if you know the base, and the height, you multiply together and divide it by 2. That's a classic formula that we are going to know. We are going to see. This is going to be the case. And then if you want to see why this is the case, look at this one. Not bad to know that. You see, if you want to prove this one, you see, we make it into a rectangle, if you like. You see, this is the way they do it in geometry. Okay, this is going to be the case. Then the way they are going to discuss is, you see, now we have 4 triangles. 1, 2, 3, 4. You see, these 4 triangles, if you put them together, and that's going to be the total area. So the area of this shape over here, you see, this area that you are going to have is going to be what? The area of the rectangles is going to be B times, okay, B times H if you like. Okay, so this is, the area of all these triangles are going to be the same if you like. So the total one is going to be equal to the pH. Okay, so as you can see, it's going to be 4 parts. So your case is going to be this one. So, it's going to be 1, 2, 3, 4. But if you want to consider 2 of these, so that gives you the area of a triangle to be equal to the 1/2. It's a proof in geometry, if you like. Okay, but we would like to get this one. So this is classic. But what we would like to do is, how can to do it in using the trigonometric format? Okay, if you have some information, you can use the trigonometric one. You see, look at this one. So this is going to be what we know. Okay, but now we say that if the information, if a triangle, okay, if a triangle with this case, you see, if you given 2 sides and the angle in between is given, okay, then we can find this area nicely. Look at this triangle. This is going to be your triangle, okay? So the information that we have is going to be, suppose this is going to be Okay, it's going to be A, B, and C. It's A, B, and C. And suppose you give me this angle, okay, and these sides. So you give me C and the, okay, you give me C and the B. Okay, you give me C and the B, then I can find, okay, I can find this, the area of this triangle for you. So what I can do is, I can draw the height. You see, this is going to be the height, H. So I should find the height. So I consider this the right triangle. And you know that in the right triangle, I can use the sine of the A to find the H. You see, and remember the sine of A. The sine is what? Is the opposite side, H, over the hypotenuse, which is going to be the C over here. Okay. So if I cross multiply, so H would be C times sine A. Okay, but the area of a triangle is 1/2 of the base times the height. So if you bring it here, that gives you 1/2 of the BC times the sine of A. You see, very easy formula. So the area of a triangle would be 1/2 of a product of the B times C times the sine of the angle in between. You see, the area of a triangle, the area of a triangle is going to be half of the product of two sides, okay, two sides times the sine of the angle in between. So the angle in between means, similarly, so look at this one. Similarly, can be 1/2. You can pick any two sides you like. If you pick the A and the C, so the sine in between would be the sine of the B, the missing one. Or if you pick A and the B, then it's going to be the sine of the missing one, sine of the C. Okay, so it's very easy formula to get this. It's not a new, you can find these heights all the time. So basically what we did is, so this is it, the area. Okay, the area of a triangle, is going to be, is half, 1/2, okay, 1/2 the product, 1/2 the product of two of its sides, two of its sides times, okay, times the sine of their included angle, means the angle between those two lines, those two sides, included angle. So it's just a modification of that formula that that you have. Basic formula, we can give you one question on this one, you just apply it and that would be fine. Okay, so it's a 1/2, you pick any two sides you like. So it's going to be sine of the missing one. Sine of, this is AC sine B, AB sine C, BC sine A. It depends on the given information. You'll be able to find it. That's it. Okay, just one example and then you'll finish it. Any question? So these are going to be, useful if you want in future. It depends on what you are going to do in future. It's we have some application problems sometimes in geometry. It depends on your field, in structure, when you get these type of problems. But it's not bad, to know it in advance. So this is the last example. And the example for this one, and one question on the final. Find the area. Okay, the area of a triangle. Triangle with this information. A is equal to the 8 inches. B is equal to the 6 inches. And the angle C is 30 degrees. That's it. So since A and the B is given to you, you go with this formula. K equal to the 1/2 AB sine of the C, and the C is already given 30 degrees. Just substitute, get the result right away. Okay, we just put it over here for you, so I can have all the information. So this is going to be the solution. So you decided that the formula is based on the given information is 1/2 AB, but cosine of the C. I'm sorry, sine of the C. Sine of the C. Okay, so it depends which information is given. So we just substitute, it's going to be 1/2. A is equal to the 8. B is equal to the 6. Sine of 30 degrees. So it's going to be equal to the, 6 times 8 would be 48. And the sine of the 30 degrees is 1/2. Okay, you simplify it. So 1/2 times 1/2 would be 4, and this would be, 12. So K is going to be 12. Okay, it's going to be the area. Remember, this is the area. So these are inches, so it's going to be a square, square inch. Okay, so it's going to be inches squares. Remember the unit. So that gives you the area in question, okay? In your book, there is another formula, a classic formula. They call it Heron formula. Okay, that's something from the past, that if you have 3 sides, you can do it, but we are not going to discuss it. If you want to see it, this is the from classic geometry, the Heron formula. Okay, it's going to be the square root of, s times s minus a. Sometimes you call it p, not s. In your book, they call it s. And this is half of the perimeter. So s is 1/2 of the perimeter. And if the 3 sides is given to you, just substitute, get the result. There are different ways to prove it, but one way is just use these cosine formula that we talk about. That's something fun.